Hello everyone, I'm Lawrence Bishop, the tech lead at Cinder. In this session I'll be covering some of the tools and techniques that we use to put more control into the hands of our designers. So let's begin. When we started work on Skeleton Crew, one of my main goals was to reduce the amount of time that code acted as a bottleneck for design. As much as possible, I wanted changes to be makeable by anyone on the team instead of requiring requests from code. Today I'll be talking about three main elements that formed the core of that approach: low responsibility components, connecting the functionality of those components together with Unity events, and the many uses that we found for scriptable objects. So first of all, let's talk about low responsibility components. These are small, lightweight components. They have control over a limited number of properties. For example, a component that scales or tints an element of the UI. And doing things this way makes the code easy to understand and maintain. If it's just simple functionality, when you open the code file, you have very little to read through, and it's very clear what that behavior does. We use these to isolate pieces of functionality so that they can be reused in different circumstances throughout the game. Let me show you an example. So, you see here this character Elgar. He has a ranged attack that he throws an axe. It goes out in a curve, it jumps, hits the enemies, because it just follows a path. Whereas this other character, Draco, his projectile, the bat, when he jumps, it homes to the target enemy. Now, the only thing controlling that is the VG target homing script, which, let's put it onto the axe and show you that it's just that simple to add the functionality. So I add the component VG target homing. I'll set the speed to 15, the homing strength to 10. The target layers, so this is a layer mask that selects which objects the projectile will home towards, and the homing radius, that's fine. The conditions are optional extras that will control the circumstances under which the homing will occur, and I'll come back to these later on. But let's have a look at Elgar's axe now. So you'll see, as before, throw it and it hits the enemy, but if you jump now, it will track down towards the enemy, just like Draco's bats would. And similarly, that same functionality is on the collectibles. You see those spirit orbs. They fly towards Elgar, but the coins just roll loosely because they don't have the target homing. So I'll show you that can easily be changed as well. If we simply add target homing to the coin, I'll give it similar values, but this time I'll set this one not able to fly. So that it will roll along the ground rather than leap into the air. And let's have a look at the change that has done. Everything comes towards. I'm not sure why I clicked that on. And there you have it. Now, isolating functionality is not just limited to simple components. It can be very helpful for even more complex situations. For example, the characters in our game so the Black Knight is the character I was playing as. They all have a VG animated character script. And in a lot of games you may create a concept of a player script that controls input, animations, state, a very unwieldy object altogether, but this VG animated character state separates input, so it doesn't control the input responsibility itself. It just receives inputs and then converts those into actions. The benefit of this is that the player characters will receive input from the player manager object, which is routing the gamepad or keyboard inputs directly into the characters, whereas AI enemy characters use the same animated character script, but instead receive their input from their AI character component. Instead of directly moving or adjusting how the character behaves, it generates virtual inputs and sends them to the character class. This approach means that, should we want to, we can easily switch a character from being player controlled to being AI controlled just by changing which components are attached. So it's all well and good having a bunch of components with various capabilities, but you need some way of letting them communicate with each other and activate or control each other's functionalities. Unity events are a variable type that allow you to hook up arbitrary functions in the editor, as long as those functions have a maximum of one parameter. Now, the most basic use of those would be in trigger boxes or switches that, when activated, cause something to occur within the scene. So let's have a look at one that's already set up in this scene. So you see that switch on the left. Step on that. Releases a boulder that crushes the enemies. Now that's hooked up entirely via Unity events, and I could change that very easily to do something completely different. So let me see, that's on this pad. So this, when the event is triggered on, it triggers the object spawner, which releases the boulder onto the enemies. I could do something directly to one of the enemies if I just drag that in there, and then you can choose from this, whichever components are on that object you can affect directly. So I could just make this skeleton receive damage without going via the boulder that was released a moment ago. Put in a large number so it'll kill the skeleton immediately. And there we have it. We also can use things from assets that we have. So I've set up various pools that we can use. So we use it to trigger VFX and SFX throughout the game. For example, let's have an ice impact. And play that at the location of this floor pad. See, the ice just bursts out of the pad when pressed. So these offer a lot of flexibility to designers and animators. Animators in particular, because we have various animation events. So when the animation encounters tags as specified, they will trigger the event that is specified within this array structure. And that means that the animator can coincide VFX, SFX, when things become damaging, whether enemies can move, all sorts of various things to the exact moment in the animation that makes sense for that to occur. So scriptable objects we've used for many different purposes. The most basic of which is easily swapping bundles of data. So configurations for components that control how they behave. If you put them into a scriptable object, you can just hot swap and change the functionality quite quickly. So the most basic example that we have is probably the larger exterior, the game config, which is a bunch of variables that are available globally. These are things that we don't want to change per instance, so it's good to have a singular place to go to adjust these variables. But also, attacks are scriptable objects. So if we look at the melee weapon on this skeleton archer, sorry, not the archer, if we look at the melee weapon on this basic skeleton, we'll see it has a list of attacks, and each of those has a number of variables controlling the behavior of the attack and the animation associated with it. So if we wanted that skeleton to have different behaviors, we could switch out the attacks on the weapon and it would have those attacks available to it. It's worth noting that while these can store a variety of data, you shouldn't try to use scene references, as scriptable objects are assets, so they won't serialize scene references. And you'll lose that data. It will work during the editor, but you'll lose that data at runtime in builds, and it'll cause you nightmares. Another use that we have for scriptable objects is small pods of functionality. So changes in behavior. The AI is a good example of this. So if we look again at the AI controller, the AI character for the skeleton, you'll see he has an attack behavior, a defense behavior, and I've currently got nothing set on the idle behavior, so he just stays still. But if I add in a 2-tile pace, you'll see when I start up again, he will just move back and forth, patrolling a small area. There we go. And so we can make a number of different idle behaviors that will allow the designers to switch what each enemy does just by swapping which of these nodes are used in the AI character script. A caveat for that is that these scriptable objects shouldn't contain any state. They should only contain information used to apply to a state. This is because these skeletons will, many different AI characters will be sharing these same scriptable objects, and so if there was state contained within the scriptable object, they would all be sharing the state. So timers or various other parts of state. Coming back to the homing, the target homing in the spirit orbs, we'll see that I'm using the condition here, can collect spirit, which means that the spirit orbs will only home if the target that they select has a requirement of being able to pick the spirit up. So these conditions are just simple functions that return true or false, and they can be used in a lot of different circumstances. And we use them for save state, so seeing whether the player has unlocked various things, and the state of the character, only triggering things when certain aspects of the character change. And this is very flexible. So similarly, we could have the gold only home when they've unlocked an upgrade with a coin magnet. So scriptable objects also allow for cross-scene communication. You may have noticed in our scene that we have multiple different scenes loaded at the same time, and the reason for this is certain things need to remain loaded throughout the game. So the system scene contains things that are loaded from the very start of the game all the way through. They're always used at all times. The in-game scene contains things that are used only in in-game levels, not during the menus, and then the level scene itself contains everything specific to the level. Now, you can't cross-reference between scenes within the editor, but if two different objects have a reference to the same scriptable object, one of them can set a variable on the scriptable object, while the other, then the scriptable object fires an event, and the other scene object can receive that event. So an example of the way we use this is in our UI. We have the resource bars, health and resolve for the player, and you see this P1 health variable that is assigned to whichever character is player 1. So when that player's health is reduced, it fires an event, and the UI receives that event and adjusts the length of the bar and flashes its color. And because of using these scriptable objects, these players don't need to be in the same scene as the HUD, and that's very helpful and usable in many places. Lastly, you have this concept of changeable enums. So in many circumstances, you'll want to have a set of types. So for example, damage types, and you may want different behavior depending on which damage type is applied. Now, normally you would write an enum in the code, and anytime someone wants to add another member to that enum, you would have to edit the code, rebuild, and then that would become available to them. But using scriptable objects, we have a really basic object. It doesn't contain any data, but each single scriptable object is unique. So you can compare for whether that scriptable object is used just like if that enum was selected. So if we look at the melee weapon on the skeleton, you'll see it has the slash damage type. So when it does damage to any damageable, that damageable knows that it is being hit by slash, and if it has a specific response to slash, then it will execute that. This was our initial approach to this idea of changeable enums, but over time I came up with another approach, also using scriptable objects. So we have these flexible enum scriptable objects where the entries can be added to a list, and when you click update, it generates an actual code enum, or regenerates one if it already exists, that can then be used for drop-down selection and can be used for flags. And this is extremely powerful and flexible, and I definitely will be using this going forward. So, to wrap up, having simple components with limited responsibility allows you to use them in multiple different places, but you can also combine them together for much more complex behavior. If exposing the controls within the game, within these components, and allowing hot swapping with scriptable objects allows for very quick iteration, which means that design can try things out, unhindered, and unexpected inspiration will occur, new ideas will come out, and may lead to requests for other types of functionality. There's a lot of tools available in the Unity editor, and you should use every single one available to you to get the most out of using this environment. I hope this has been a helpful talk and has offered some insight into our process. If you have any questions or comments or want to tell me I'm doing something wrong or just want to talk, I'm at Banjoses on Twitter. Thanks for attending this session on empowering designers with modular structure. And that is all.